Let's look at frequency trees. So frequency trees are useful diagrams that help us display data for two or more categories. The example says 50 people took a test, 30 people predicted they would pass, 26 of these people did actually pass, and 37 people passed altogether. Complete the frequency tree. So for this example, we have two different categories. The first is the prediction, whether someone predicted they would pass or fail, and then the second is the result, so whether they actually passed or whether they actually failed. And so we first see then that 50 people took the test altogether. And so in this first circle, in the beginning, we can write 50 to indicate the 50 people that took the test. Then we're told that 30 people predicted they would pass. So if we look at the prediction category, we see that this branch is indicated for pass, and so we know that 30 people passed altogether. So we can write 30 within this circle. And so if 30 people predicted they would pass, then to work out the number of people who predicted they would fail, we would do 50 minus 30, which gives us 20. And so within this circle, we can write 20. Notice how the two branches that come out from this circle have numbers which both add up to the number inside. So 30 plus 20 gives us 50. And this is always true for all of the other branches. So for 30 here, the two branches that lead out from this circle, the two numbers inside must add up to make 30. And likewise for 20, the two branches that lead out from here, the two numbers inside these circles must add up to make 20. So we have that 30 people predicted they would pass, and 26 of these people did actually pass. So if we think about the result now, of the 30 people that predicted they would pass, 26 did actually pass. So we can put 26 in this circle, and now to work out the number that goes in here, the calculation would be 30 minus the 26 people that actually passed, which gives us 4. Therefore, 4 people who predicted they passed actually failed. We're also told that 37 people passed altogether. So if we have 26 people that predicted they would pass and actually passed, then the number of people who predicted they would fail but actually passed would be 37, since that's the number of people that passed altogether, minus the 26 here, which would give us 11. Therefore, 11 people predicted they would fail but actually passed. And so if we want to work out the number in this final circle, we know that these two circles must add up to make 20, and so if we do 20 minus 11, we end up with 9, which is the value that goes inside this circle. And so this is our completed frequency tree. Let's look at this final example, which says 50 people took a test, 30 people predicted they would pass, 36 people did pass. Of the 36 people, 3 times as many predicted pass as predicted fail. Complete the frequency tree. So this is very similar in wording to the example from before. However, there is a slight difference in this question. We have that 50 people took a test, and so we know that 50 is the total number of people, and so that goes in the first circle. Of these 50 people then, 30 people predicted they would pass. And so in the prediction, we would say the number of people that passed is 30. And so therefore, if we have 30 people that predicted pass, then there must be 20 people that predicted fail, since both of these numbers must add up to make 50. We're then told that 36 people did pass. In other words, in total, for this circle here, we'll label it as number 1, and this circle here, which we'll label as number 2, both of these give us results of pass. And so we know that circle 1 plus circle 2 must add up to make 36, since 36 people did actually pass. We're also told that of the 36 people that did pass, 3 times as many predicted pass as predicted fail. So if we make sense of this sentence, 3 times as many predicted pass as predicted fail would indicate that people that predicted fail, if we represent that as one part, so this is the number of people that predicted fail but actually passed, is given by one part, then we know that 3 times as many predicted pass, and they actually passed. So for this region, number 1, we can label that as 3 parts. And so in our equation then, we would have 1 as 3 parts, plus 2 as 1 part, which would equal to 36. So in total, we have 3 plus 1, which is 4 parts, which is equal to 36. And so 1 part, if we want to work this out as a number, we divide both sides by 4, and we get 1 part equals to 9. In other words, the number of people that predicted fail but actually passed is equal to 9, since this circle represents 1 part. And so we have 9 inside this circle, and we know that both of these, 1 and 2, must add up to make 36. And so to work out the number of people that go in this circle, we have 36 minus 9, which equals to 27. And so we can write 27 inside here. And so finally, to fill in the rest of the circles, we know that the 2 branches that come out from this circle must add up to make 30. And so to work out this circle, we would have 30 minus 27, which equals to 3. And so 3 would go inside here. 3 plus 27 is 30. And then finally, the number that goes inside this circle, the calculation would be 20 minus 9, which is 11. And so 11 plus 9 gives us 20. Therefore, we've completed the frequency tree for this question. So the key thing with frequency trees is to first understand the wording of the question and then work your way through the frequency tree based on the information that we're given in the question.